The midpoint is a point right in the middle of a segment, right at the halfway point. So if we want to do this graphically, we'll take segment AB and find the midpoint. We just have to count the distance from A to B. So going down, starting at A, I would go down 1, 2, 3, 4, 5, 6, 7, down 7. And then I would have to go over to the right, 1, 2, 3, 4, 5. Well, I would take half of that distance. Half of 7 is 3.5. So let's go back to point A. So down 1, 2, 3.5. Over to the right, half of 5 is 2.5. So I'd have to go right 1, 2.5. And right here is the midpoint. So if I called that midpoint C, I could say that the distance from A to C is congruent to the distance from B to C. What if we don't have a graph? What if we want to solve it algebraically? Well, here's the midpoint formula. Really what you're doing is finding the average or the mean of two numbers, right? So we would take the two values, x plus x, divide by 2, and do the same thing for the y's, add them together, divide by 2. So that's where the formula comes from. All right, number 1. What are the coordinates of the midpoint of this line segment with endpoints? We have 2, -6, and 8, 3. Now, before I plug it into the formula, what I like to do first is go over the points and label x, y, x, y. Sometimes people mess up the x's and y's, so if you label them right away, you're less likely to screw it up. Okay, x plus x. Now, let's start with the first point. So I'm going to do 2 plus the other x, which is 8. Divide all of that by 2. Okay, now when you go to do the y's, you have to start with the same point you started with the x's. So if I started with the 2, I have to then start with the -6. So y plus y, -6 plus the other y, 3. All of that divided by 2. Next step is you want to just add the numbers on the top in the numerator. 2 plus 8 is 10. Okay, and then the other one, -6 plus 3 is -3. Divide by 2, and at this point, just reduce it down. 10 divided by 2 is 5. -3/2, you can leave it as -3/2, a fraction, or you can write it as a decimal, -1.5. Either one would be correct. Just make sure that you have parentheses around your final answer because it is a point. One more together. In the triangle below, number 2, BD is a median. Median goes to the midpoint of the opposite side. What are the coordinates of point D? And we have to solve this algebraically, so we want to do it using the formula, not using the graph so much. But let's kind of look at the graph and see where D would be about. Well, it says BD is the median, so the median would go from B, and then D would be the midpoint of the opposite side, so like somewhere around here. Well, that's going to be the midpoint of CA. So if we're using the formula, we have to write down the points for C, which is 1, 3, and A, which is 4, -1. Okay, so we're going to use the formula, but let me first label above x, y, x, y. Okay, so x plus x over 2, I'm going to start with the first point. So it's going to be 1 plus, the other x is 4, all of that divided by 2. Do it for the y's. Let's go back to the first point, 3. It's going to be plus the other one, plus -1. But 3 plus -1 is really just 3 minus 1. So I personally don't write plus and negative. I'll just change it to subtraction when I write it out. But whatever works for you. And you're dividing that by 2. Next step, add the numerators. 1 plus 4 is 5. Then 3 minus 1 is 2. Divide that down. 5 divided by 2 is, well, you can leave it as a fraction, or you can write 2.5. 2.5, comma, 2 divided by 2 is 1. So this is the midpoint of segment CA. Let's just graph it out just to see if it looks correct. 2.5, and then I would go up 1. Right here is the midpoint, so that would be point D. Okay, my line's not going to be so great here. I can't get it back to the other screen without kind of screwing it up, but nice and curvy for you guys. There's our median, BD. Next formula we're going to look at is the distance formula, and this is when you find the length of a segment. So looking at number 5, this is to find the length of AB to the nearest tenth. Okay, so the formula is big square root over x minus x, the whole quantity squared, plus y minus y, the whole quantity squared. Okay, so first step is label x, y over your points, just like we did in the midpoint formula. Okay, we want the length of that segment, so we're using the distance formula. Let's first write out the formula. You guys do have to memorize this, so You should be writing out every problem on this worksheet, just so it kind of sinks in a little bit. All right, next, just plug in the numbers. Remember, whatever point you start with, you have to start with for the x's and the y's. So just let's both start with a for both. Okay, x minus x, so that's negative 3 minus the other x is 2. That whole quantity squared plus parentheses again. Now go back to the first point, which was point A we used. So y is 4 minus the other y. Watch this. We're subtracting the other y. We're subtracting a negative 3. What happens when you subtract a negative? Subtracting a negative becomes positive. So I will always just change this to plus. Yes, you can leave it as minus negative, but it's really just addition. Now at this point, what you're going to do is just not the radical. Don't touch the radical. Don't touch the square root button. But everything underneath the radical you want to put into the calculator. Problem with doing it by hand is honestly sometimes a lot of people screw it up, squaring it incorrectly, adding it incorrectly, the negatives, whatever it happens to be. So I just teach it as everything under the radical, everything right here, put it all into the calculator. Now when you do this question, you end up getting 74. Question says to the nearest tenth square root of 74 is, you just type that in the calculator, 8, oops, sorry, I got a little crazy here, 8.6. That's the length or the distance of that segment. Okay, let's do one more here. The directions are just a little bit different in number 6. It says, find, this time in simplest radical form, so we have to review how to do that. Find the length of the line segment with those two endpoints there, or find the length of the line segment with endpoints whose coordinates are. So those are the coordinates of the endpoints of the segment. Okay, so I'm going to write the formula. And next step, remember, label the points. I'm going to do it under so you guys can actually see my x's and y's better. It's not going into the words as much. So x, y, x, y. This formula is easy because really the calculator is doing most of the work. All right, so let's start with the first point. So x minus x, that's negative 1 minus the other x, 3. The whole quantity squared plus y minus y. Go back to that same point you used. We used the first point. So 4 minus, right? The formula has a minus. We're subtracting the y. The y is a negative 2. If I subtract a negative 2, it's really like adding a 2. The whole quantity squared. Remember, put this into the calculator. Do not type the square root button. You want to type everything under it exactly how it is. So like if I'm typing it in, I would type parentheses, negative 1 minus 3, close parentheses squared, plus just all of this right in the calculator. Okay, when you do that, you get 52. Now this question says in simplest radical form, we got to go back to review how to do this. You need your perfect squares list. So start at 1, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and I'm going to stop here. You want to start, actually let me do one more, 6, 7, 8, I'll go to 64. You figure out where's 52 in the list. Well, 52 would be here, right? And I work my way up to find the largest perfect square that divides into 52. So if you're using a calculator, you would do 52 divided by 49, decimal. 52 divided by 36, decimal. 52 divided by 25, decimal. 52 divided by 16, decimal. Usually there's a larger one, just not in this case. Okay, 52 divided by 9, decimal. But guess what? 52 divided by 4. 4 is the largest perfect square that divides into 52. All right, so I break it down into two radicals. 4 is the perfect square that goes first. And if you divide it out, 52 divided by 4, you get 13. So 4 times 13. Next step is to take the square root of the perfect square. The square root of 4 is 2. And I would leave the radical 13. So if it says simplest radical form, use perfect squares. In this case, we got 2 radical